CERN is the European Laboratory for Particle Physics. We were founded in 1954 as a place where fundamental research could be done. It allows 13,000 physicists from around the world to understand the universe, how it works, what it's made of, using some of the most complex and largest pieces of scientific equipment in the world. So CERN's flagship experiment is the Large Hadron Collider. This is a 27-kilometer ring, 100 meters underground on the border between France and Switzerland. And with this we fire around 2 beams of particles at just below the speed of light and collide them at 4 different places around the ring. Here, massive detectors the size of Notre Dame analyze the data and produce around 1 petabyte a second. This then has to be processed and analyzed and stored. As a set of IT challenges, this is a large data problem. So with this, we have a central store of around 180 petabytes. We recorded, I think, 50 petabytes last year. And we use an OpenStack-based cloud of around 200,000 cores to do the first pass analysis of this data and then distribute it around the world to over 100 different labs that collaborate with us to understand the physics behind these collisions. So the data needs at CERN actually vary significantly. We find certain circumstances where, for example, coming up to a conference, we would like to be able to increase our compute capacity significantly in order to complete those results on the time that we need. Therefore, it was interesting for us to find a way that we could expand the center in a dynamic fashion, and using public clouds was a clear way to provide that. We've been investigating the use of public clouds over the past few years, and as part of that, during 2016, we ran a public open tender, which was won by the Open Telecom Cloud, to deliver compute capacity to the LHC. The benefit of the Open Telecom Cloud was that since it was compatible with OpenStack, then that allowed us to use the same tooling that we have used on-premise and expand the resources in a transparent fashion to the public cloud. So during a period of 3 months, we ran a 1,000 virtual machine test on the Open Telecom Cloud, processing production workloads from the 4 LHC experiments, Atlas, Alice, CMS, and LHCb. And with that, we were then able to run those services in a transparent fashion on the Open Telecom Cloud. As part of this, we also used storage in order to cache data that we would otherwise have had to transfer each time from the CERN Center to the Open Telecom Cloud, and that allows us to deliver a faster performance for the end users. For future collaborations with Huawei, we're looking in 2 areas. The first is using the extreme computing challenges of the Large Hadron Collider in an industry research partnership called CERN Open Lab. We're looking to work with Huawei to be able to analyze the problems of running OpenStack clouds at scale. The aim behind this will be to work with the open source communities upstream so that changes we make are available to other labs that we collaborate with, but also will come available to OpenStack clouds like the Open Telecom Cloud. Secondly, the other area that we're looking at is around a project called the Helix Nebula Science Cloud. The Helix Nebula Science Cloud is a pre-commercial procurement as part of the European Union Horizon 2020 activities, where we're exploring, along with a number of other science labs, what we would need as public clouds for science. And currently, the Open Telecom Cloud is part of 2 of the consortia that we are looking at as part of those activities.